Alright, welcome back to my development series. This is Steven from RC Engineering, and we're back with the Eachine VR006s, and we're going to go ahead and take them apart and look inside, take some measurements, and see what we could do about making that jig this coming weekend on the next episode of the development series. So, first thing we're going to want to do is take the antennas off here. And then you want a Phillips head screwdriver here. And there are 4 holes here. One there, one there, one there, and one there. So another thing we're going to also have to do to get all the boards out is we're going to have to take the nuts off of the antennas. One there, one there. So let's go ahead and unscrew these guys, and I'm going to want to have a safe place to put them. Let's use this box. This box will work perfect for that. Let's put that guy up there. So yeah, just go ahead and unscrew them. And everything also you're going to need is you're going to need a knife, because you're actually going to have to cut a slit in the foam in order to separate it. Let's go ahead and open it up. There's another one. And be careful when you're screwing these guys back in. This is just plastic, so you don't want to be too crazy on it. Alright, let's go ahead and looks like one more is hanging in there. Go ahead and put that in the box. And it is that one? Yep, it's this one right here. Saved it before it fell off the table. Okay. Now what you're going to want to do is you're going to want to take a slit through this foam right where that seam is. So go ahead and get your razor blade, right? You're just going to want to come down this seam here, and then you're just going to want to cut it right down through that seam. Try to do as little foam damage as possible. See that? I just went right through it. And you can see it'll open up once you go right through it. But you want to also make sure you're right through it, because you'll cause way more damage if you don't go all the way through. And you see when you see how it opens there. But when you put it back together, you can't really see that it's been cut. So just in case you want to resell the goggles, you can't tell it's been cut. And then we're going to do the same thing here. We're just going to kind of slide back and forth, back and forth, back and forth, back and forth, until we're into the frame. There it goes. So cut here. So you see now it's free. And so now what you can do is move the strap out of the way, and the bottom comes out, and there's nothing in the bottom you really have to worry about. But when you take it apart, the strap comes off. That's another thing that we could take off really quick. Take off the strap so it's not in your way. There you go. Strap's off. Throw that aside. And there you go. So here's what the bottom looks like. This is the bottom of the frame. You can see here on the bottom. This is the ribbed portion here is the bottom. And you can see here what I really liked is how it had this. This is the anti reflection stuff that was inside there. It's just a piece of foam, but you notice that it does not have it on the side walls back here. This is just really shiny plastic, and it does not have it on this side either, but it has it on the nose piece. There's felt right there on the nose piece. So I don't know why they didn't put little pieces on the sidewall to keep it from reflecting, and also you can see here on the top there is nothing in there. So nothing much really to see in here. I mean, so here we have the slot for the Fresnel. See there, and here's the slot for the LCD and the board. And then let's go ahead and look at where the action happens. So here is here's the top portion, and here you can see the board for all the buttons, and all the buttons just kind of sit there, right? And you see it's doing stuff. That's weird. It flashes that light. Anyways, then here you can see the board. So right there you can see this right here. You can see the board for the receiver. But what I'm going to do, if I'm going to be touching this stuff, I'm going to disconnect the battery really quick. There's the battery cables right up here. I'm just going to kind of work it out until it comes out. There it goes, it's out. Okay, so whenever I'm going to be touching stuff, I'm going to disconnect the battery. There's the battery cable. There's the connector where the battery goes into. And here's the board itself on the inside. There's the big receiver right there. And then I'm guessing that it has some sort of internal receiver there. We have another plug up here that goes to the buttons. So that is completely adjustable for our own use on building another frame. So what I'm going to do is I'm going to just kind of gently gently move it out. I'm going to use a bigger screwdriver. Basically what you want to do is you want to put the head down into the little foot thing and just turn sideways. Kind of rock it back and forth against the plastic piece. That way you'll get it good. And let's grab hold here and we'll take it out all the way out. This one is really difficult to get out, unfortunately. But we need to get it out in order to remove the board. There it goes. Now it's out. So that's the buttons. You don't really need to mess with that because that's unnecessary to mess with. Another thing you'll see, so my roommate's one, this battery here on his, it actually had a foam piece in here. This one does not have one. It's actually just glued onto the sidewall. But this is actually a 500 milliamp hour. I don't know if we'll be able to tell because we would have to rip it off of the side, but yes, it is 500 milliamp hour. And here we can see the Fresnel, really cheap little Fresnel. So what we're going to do to take the board out, to take some measurements, is we need to take a crescent wrench, right? We need to undo these little nuts here at the top. Very carefully. They're not really on there that tight, and I know that because of my roommate's goggles that we took apart. Can maybe even do them by hand. There it goes. It just takes like a slight twist from the crescent, and then they spin off. So there it goes. They spin off. Now something very important that you need to keep track of is which way these rings, these little retainer rings go down. I mean, it's not super important, but we're just going to keep track of that. Let's go ahead. We're not gonna keep track of how this one came off. We're gonna keep track of how the next one came off. So let's go ahead and put that in our little box. And let's go ahead and take this other set off. There it goes. Okay, now how is this guy going on? This guy is going with the ribs. The ribs of it facing upwards. You can see there the ribs are facing upwards. Okay, let's go ahead and there it goes. Alright, now the board with the LCD, which I just put a fat fingerprint on, we're gonna clean that off before we put it back in. Hopefully I remember to do that. So you just kinda, and it slides right out. There you go. There's your LCD screen with all your stuff on it. Let's take a quick look at the board. You could see there on the board that we have lines coming out of the center pins. Let me get my other finger up there. Center pins up to the receiver. You see at the top there we have the AV in jack. Right here by this finger we have where the LCD plugs in. We have some other various ports here. Looks like quite a few of the chips have their numbering worn off, so that's pretty cool. This is a version 03 of the board. It says AV30001 at the top. We have some 3.3 volt power up here, 3 volt reset pin. SWIN, so SWN, sine waves, something. Reset pin, ground, and 3.3 volt. And then here's audio up here, audio AV. So audio AV, V battery, and ground. So that might be easy setup for the. So you can see it up here. I don't know if I can get that. Yeah, this stuff up here. So audio, AV, V battery, and ground. So that might be easy pickup for a DVR. There's a few of them already out of the DVR, and they like plug them up into here, up onto the receiver. But I'm thinking maybe just go off those, because I mean you can sort of see where those pins go in to through using the traces. But yeah. Also, I see that one of the pins here is not soldered on these guys, but they are indeed routed to the receiver, so it is indeed using those. So yeah, so we could use we could use a few things. Let's look on the back side of the LCD very carefully. Okay, so we have like something pushed in there. I don't know, it looks kind of like a little capacitor or a little rectifier or something. We have no screen printing on the back side, so nothing really super important on the back side. You can see here that these guys are really tall. Again, they're RPSMA. Yeah, so what we might do, if we have some time at the end, we'll take some measurements. We'll take some measurements of the battery compartment here. So if you guys didn't want to do that, we could see what we could do. But let's see if I could, like, so see what we could do about the Fresnel. Fresnel might be glued in. Oh no, it's just in there very tight. Another thing very important on this guy is to know which side goes forward. So what I'm gonna do, I can find my tape. some very non-sticky tape. And I'm going to make sure that I get most of the stick off of the tape. So here I got some tape, some really crappy HDX tape from Home Depot. I'm just gonna kind of get rid of a lot of the stickiness on there so it doesn't leave any residue. And then let's go ahead and stick it on the front side of the Fresnel. And then let's go ahead and pull the Fresnel out very carefully, trying to get as few fingerprints on there as possible. And without breaking it, there it goes. And there's the Fresnel lens. So yeah, it has a little piece of something right there that kind of holds it in there. I don't know if it was glue or what it was, but it tried to hold it in there. Another thing also, we want to know which side's bottom. Let's go ahead and put another piece of tape, show which side's the bottom. So let's go ahead and grab another piece of tape here. Let's see if I can rip it. And there we go, there's the bottom. Alright, cool. So now there's the Fresnel. Obviously I put tape all over it, but get the idea what side's front, what side's back. I'm going to make sure we clean this guy off really nicely before we put it back in there. So just looking at the Fresnel, it's kind of got this prism effect. It's pretty flat, luckily, and looks pretty good. So what we could do at this point is we could take some measurements, and obviously the battery is glued on there with a foam sticky back pad, and the buttons just slide right off, right, and they slide back in, and then you could use all the little buttons. So we could also take the buttons out. Here's the button piece, and we could take measurements off of that, and then here's all the pressing pieces for it, and that's pretty much all we could take off. It's completely disassembled, besides of course ripping off the battery there, which we could, to look at the weight, to kind of compare it with what we're looking at, or we could go, like I said, online they have replacements. I do not think they put the specs of the replacement on there. But, and also the funny thing is it just uses a little, it just uses like a regular little motor connector on it. Pretty much everything on here just uses a regular little motor connector. Okay, so at this point, everything is taken apart on this guy. Let's see if we could write down some measurements. I have an inch caliper here. Here's an inch dial caliper. My dad's pretty old. I actually dropped it once, unfortunately. Move everything else out of the way over here. Put this guy back over here. Screwdriver, crescent wrench. We'll use that when we put it back together. Alright. So let's go ahead and take a few measurements. So this is the VR006 measurements. First, let's start off with Fresnel. Fresnel lens. So let's see here. And there's a few etiquette on how to properly use calipers that I'm not going to go into right now. Okay, so we got 0.910, 0.910. 0.910, yeah. Making sure that's straight. 0.910. So I'm going to do this. I'm going to do a little drawing. .910 wide. So this is 0.910 that way. See how long it is here. You want to make sure that it's straight and the caliper's as straight as possible. Okay, we're looking at 3 inches 3.262. 3.2, I'm going to try again. Get it as straight as possible. 3.262. 3.262. Okay, so that's this way, 3.262 long. And now thickness, be very careful not to scratch the Fresnel lens here. Okay, this is 0.65. 0.65. So 0.065 inches thick. So of course that's this way, 0.065 thick. All right. So that's it for the Fresnel. I'll put it in here like that, just to store it. Okay. Now let's take a look at the actual size of the screen. So let's go ahead and put my notebook down over here somewhere. And then I'm going to move the bottom side with the Fresnel off the desk so I can store this guy in sort of underneath my printer, kind of over here. What's going on? Oh, it's too big, but it's okay. Okay. So let's look at the actual size of this guy without bumping into the screen with anything. So it looks to be indeed about 3.16. 3.155 diagonal. So from here to here, 3.155 diagonal. Okay, now we're going to just take the actual dimensions that are important to us, which are the width. So let's first write this down here. So this is the LCD slash board. We'll do LCD first. LCD is I want to be very careful here. LCD is 2 inches, make sure this thing's straight, 2.015 wide. So here we go, draw another one. 2.015. Oh, that's the wrong measurement right there. 2.015. So this is 2.015 inches. Now how about the length? Make really sure that we're not going to dig the edges of our hardened parallels into the frame of this guy. 2.7, make sure it's straight. 2.760. 2.760. It's 2.760. So this is 2.760. And thickness, this is super difficult to do. You gotta be very, very careful. We're looking at 0.90. 0.90 thick. Well, 0.090, sorry. 0.090 inches thick. So this is 0.090. And I see that when you put some weight on it, it actually will push the screen out a little bit, so be very careful. Alright. Now we're going to look at the board itself. So this is the electronics board. Okay, this is a little bit easier to do, so we're just going to have it here down on the table. We're going to go from the longest side. Yeah, we're just going to go from this corner, not where the The USB is poking out. Because again, this is not really for the designing of the new frame. This is kind of just for the design of the rig. We could take more measurements when we put it in the rig to design the goggles itself, the aftermarket goggles. That will be 3D printed. So we have 3.688. 3.688. Okay, 3.688. So this is 3.688. Oops. Yeah. Yeah. So this here, from here to here, 3.688. And then this other measurement is pretty much the size of the LCD, which is 2.015. Now, the button board, don't really need to take any measurements of it because it's just going to be hanging for our jig to do some distance measurements with the Fresnel and the LCD. But I'll just take some measurements here. So this is 0.47576. 0.476 wide, 0.476. That's this way, 0.476 from here to here. How long is it? It is 1.6 inches. 1.60. 1.60. Okay, and thickness, we're just going to go to the top of the button without pressing in the button. 0.210, and 0.210 thick. Also, I forgot to measure the board thickness. Let's go ahead and pick the board up. Do quick board thickness. Board thickness is 0.46. 0.046. 0.046 inches thick. Alright, last one we're going to do is for more of the goggle design, but we'll do it anyways. And this is the battery. The battery hole, I guess you could say. But what I would, if it was really me, I would want it to fit in this hole right here. Because you're not even going to be able to see that still. I mean, ideally, you would want it just to fit in there. See that hole right there? Just fit it in there. So we'll have battery hole option 1, which is how it is now, and then this is option 2. Okay, so what we're going to do is first we're going to check. So theoretically, the depth of this hole here is the depth of this from the ridge here, and then plus the extra depth. But as you can see here, it actually has something that would block it, right? Because here's the button side, so the battery side goes on this side, and there's actually a ridge right there. So I mean, theoretically, if you cut that out, you could do kind of whatever you want. But let's go ahead and look at. So the maximum thickness, if the piece is a rectangle, is that thickness right there. So what we're going to do is see if we get our calipers in there. And we're looking at 0.430. So 0.430, I'm going to draw a little rough. So this is 0.430. Then we have the length. And then we're just going to do from the ridge down. See if we get a better spot to do it. Not really. There we go. 1 inch, 0.7, 1. So this is the length here. 1 inch, 0.776. Or it's actually 8, but whatever. And the depth I'm going to go from the top of the battery, from the top of the seam there, down, looking at, so I'm going to put depth, we're looking at 1.512, 1 inch, 0.512. And again, for the second option, theoretically the height can be all the way down here, so it could be full depth. So if we have to do a really tall cell, we can do it. So let's look at that. Let's look at this hole right here for option number 2. This hole right there for option number 2. That is, let's do a quick drawing of it. Let's do a quick sketch. Option 2 is kind of like this, and then up, then like that. Tiny little hole, but a nice little one cell could fit in there really close to the face. So not a lot of weight towards the outside. 0.532. 0.532 wide. 0.532. Okay, now what is the smallest that you can put in there? Right there, 0.3. It's about 0.3. 0.3, and it can be extremely deep. Let's check it anyways. Okay, that's 1.520. 1.520 deep. And then that's in addition, and then you could add the extra portion from this ridge down on this goggle here. Let me see if I can do that. Yes, I can. Okay, and that is plus 7, plus 7.7, 0.760, 0.706, sorry, 0.706. So 1.520 plus 0.706, and again that's this depth here, from here down, oops, here down, plus on this side from this right here down. So because we could also get the top of the one cell lithium ion in there. All right. So pretty much everything there has been recorded. We are ready to start designing the thing for the jig, the jig itself, a 3D printed jig to hold the Fresnel and hold all that stuff together, so we can find out what's the optimal distance for myself, and also do some learning on optics at the same time, some engineering, some design equations on optics, and be able to test that in real life. Alright, so this has been Steven from RC Engineering. I'd like to thank you guys for watching this video. If you like this video, please subscribe for more videos like it. And if you would like to help support me making these videos, please check out the link to my Patreon in the description. And I will talk to you guys later. Thanks for watching. Take it easy. Peace.